Hi, so let's talk about the graph value tree. So you're given a graph of node, and then you want to return true if the edges of the given graph make up the value tree. So if a tree is like this, it's definitely okay. So you return true. If you connect, like if there's a cycle, right? You want to return false. So for example, 2, right? So there's additional line right over here. So this turn out what? 1, 2, 3 are in the cycle, right? Because this is an undirected graph. So in this question, you can use union find. So union find is pretty helpful. So union find, I can just what? So I set everything independently. How many? 1, 2, 3, 4, 5, right? So 0, 1, 2, 3, 4, right? So basically, I connect everything by 2 itself, right? So I will just set this initially, and then if I just get the edges from the to the array, right? So 0 to 1, so I would just say 0 to 1 and something like this, right? And then 0 to 2, right? Sorry, I have no idea what I erased, but and then this is 0 to 3, right? And then 1 to 4, so 1 to 4, right? So I can just check, right, if I in the cycle or not, right? So this color, so if I go from 0 to 2, right, then 2 compares 2 compares 2, right? So this is like one node cycle. This is not like a 2 node cycle, right? So this is okay. And I mean, it doesn't matter, it's 0 to 2 to 0, right? Right, 2 to 0, 0 to 3, and then what? 3, 3, 3, right? So it doesn't work, right? So this is okay. So I'm going to stop coding, and you'll be able to follow along. But you need a union find class. So I'm going to say class UF as union find. So I will have a I will have a parent, so which is going to be just point at the parent node, basically. So probably UF, I'm going to give a size. So I'm going to initialize the size for parent, and I'm going to just initialize my parent array to itself, right? So this is initialized, and I'm going to call union. So I'm going to union probably both union. So I need to know, right? So I want to find out what's my root of my current node. So what's my ancestor, right? So root A able to find node 1. So I will need to have I will definitely need the find function. So probably means, so find means like you want to find out who is your current ancestor so far. So the ancestor should be the top of the current subtree based on the node, right? So I'm going to say in find and then in node, right? So while the node does not equal to parent and node, right? So if they are not equal, right? So node will be basically like node will be 3. So if I have a 3, right? So there's a parent. There's a point that point out, right? So if the 3 does not point at itself, then I will just keep doing this because there should be someone like this guy point at, right? So while node is not equal to parent, then I want to update my parent to grandparent, right? And I will update the node to parent. So you will just keep going on the next level. So I will return node, which is the parent, the ancestor. So now back to the union. So when I find out who is my ancestor for root A, node 1 and node 2, which are root A and root B. So if they are not the same, right? So I will have to assign one of the root to the other one, right? So I'm going to say parent, and if you can say root b. So I'll point my root b to root 8, and I mean you probably have to check out the size. So if the size is actually what root 8 size is smaller than root b, so you want to connect the small tree to the biggest tree, right? And then vice versa for root b size is what less than root 8. Alright, so what do you have to do? So you want to basically like this, and also another helper function. And this should be public, right? So another helper function. I'm going to check a boolean. So I want to check if this connect a list to node are connecting, right? So I'm going to say find node 1, which is equal to what? Find node 2. And this is pretty much it, right? So again, you are missing one element. So the one element should be what? Should be the count. And then the count should be what? It should be equal to the size. And then whenever you union, like whenever you union, you want to subtract by 1. Right? And then basically this is supposed to be, right? So yeah, so let's move on to the value tree. So I'm going to create a UF equal to what? New UF based on length, and then traverse the edges, and then I will have to what? Union. So I'll say UF union edges 0 to edges 1. But if they are connect, right? If UF dot is connect, the edges 0, edges 1, you want to return false. And then later on you want to check does my union count is actually equal to 1, right? This is because like if they are the same, I mean if they remain 1, which means there's only one root, right? It doesn't connect to anybody, or I mean yes, so you will just return false. So if the union count is actually equal to 1, so this should be it. Where is it? Line 18. Oh, made a mistake. Size, right? And then parents, line 19. Should be fine, right? Yes. Alright, let me submit. So let's talk about the time and space. For the space, right, it's going to be all of n. Create a number of the in array. I mean number of the length based on the length, so it's all of n. And then for the time, this is what? All of e, right? And then you want to compare union, so every single time is what? All of 2, which is like 2 edges, right? And then you want to check the is connect, right? Is connect is a little bit painful. You want to find, right? And then union, you also have a find, right? So let's talk about this one. This is going to be what? All of h. H represents the height of the current tree. So for the worst case, right? It's going to be all of height of the tree. So I'm going to say the worst case for the time is going to be all of e times h, right? So this is my solution. So time is all of e h, and then space is all of n, right? So this is a solution, and I'll talk to you later. Bye.